Hi, everybody. I'm Tyler McMullen. I'm the CTO and co-founder of Fastly, and today I wanted to tell you about what we're doing to advance the ecosystem. So one of the things that we've always said at Fastly is that our goal is to keep our customers modern. Now, what we mean by that is that the internet evolves rapidly, right? New technologies emerge, new protocols are deployed, new techniques become commonplace for that matter. And keeping up with that is difficult. It's even difficult for like our internal applications, but so much harder when you're also trying to keep up with the edge, right? And how you actually connect to the internet. So we always try to keep your edge as up to date as possible and compatible with the latest developments. As an example, by default, you probably have never had to think about whether or not HTTP 2 works with your website. Fastly just kind of takes care of that for you. Likewise with TLS, latest developments in TLS, we roll them out and no one has to think about it. But at a certain point, we realized that wasn't actually enough. We also have a responsibility to help define what the modern internet will look like in the near future. We have a responsibility to advocate for the interests of all of you in the forums where the next generation of internet technologies and protocols are being defined. We can push the edges of what existing internet technology and infrastructure is capable of. We, can and do play games all day long with TCP tuning and routing tricks and DNS manipulation, just to make your users' experiences like just that little bit better. We do that a lot. But real leaps require fundamental change. We can iterate and tweak and futz with everything, but sometimes even that is actually hamstrung without more fundamental change. Typically, when we enter those forums, the things that we're advocating for come down to three things: trust, performance, and flexibility. In one form or another, these are always our three primary motivators. We want your users to be able to find the fastest and closest Fastly pop automatically. We want to be able to receive their connections and respond to them as fast as possible without anyone else ever being able to modify or snoop on them, right? When you run code on our edge, on computed edge, we want it to execute as fast as it possibly can without anyone ever being able to observe anyone else. Anyway, rather than listening to me like wax philosophical about motivations and intent and goals, I thought it would be far more interesting to hear from the folks on the ground who are working on some of the ways that we're advancing this ecosystem that we all kind of at the end of the day have to live in on the internet. To start with, I want to talk about HTTP 3. This is probably like one of the most like well-known things that's going on right now. It's everybody has seen this coming from a mile away ever since HTTP 2 came out. And there's a great person who can talk to you about this, and that person is Mark Nottingham. Mark Nottingham is the chair of the IETF HTTP working group. He's a member of the Internet Architecture Board. He's the author of HTTP 1.1. He's the chair of the HTTP 2 working group, not to mention being the author of 27 other RFCs. And he also works here in the office of the CTO at Fastly. So, Mark, tell us about HTTP 3.
Thanks, Tyler. So, everyone in the HTTP community has been working pretty hard over the last decade to make the web safer and faster. We started with HTTP 2 in 2012 because of what's called the head-of-line blocking problem. That's what keeps you from having more than one outstanding request on an HTTP 1.1 connection, and it's not good for performance. HTTP 2 shipped in 2015, and we've seen pretty quick and broad take-up. Browsers tell us that more than 60% of all the requests they make are using it. So why are we working on a new version of HTTP so soon after shipping that? It turns out that fixing the inefficiencies up in HTTP immediately exposed problems down in the underlying transport protocol, TCP. That means that HTTP 2 doesn't perform as well when network conditions are bad. The right way to fix that was to design a new transport protocol itself. HTTP 3 is just HTTP built on top of that new transport protocol called QUIC. So the important thing to know about HTTP 3 is that it takes away the guesswork of which protocol to use. HTTP 2 performed worse when there was high loss of the network, but HTTP 3 should consistently perform better.
Mark's words point to the fact that improving our ecosystem is an iterative process. Improving things in one area frequently expose problems in other areas. And the next step is then to address those. And this continues on and on, time after time and year after year. But one thing that Mark mentioned in his words there was about QUIC. HTTP2 exposed some of the problems with TCP as the most common protocol on the internet. TCP, again, has served us well for a long time, but its design has made it difficult to secure, difficult to optimize, and I think most importantly, very difficult to iterate on. And if we've learned anything over the past several decades, it's that being iterable is one of the most important things in these core protocols of the internet. Every time we as a community get stuck on a particular version of a technology, protocol, language, or even technique, we end up regretting it over time. So, to talk about QUIC, I wanted to pull in someone named Jana Iyengar. Jana is he's a member of the Office of the CTO here at Fastly. Again, he's also the chair of the IETF Internet Congestion Control Research Group. He's a member of the Internet Research Steering Group. He's a reviewer in the Transport Area Review Team, and he's also the author of QUIC, BBR, and LEDBAT. So there's really no one better to tell you about this. Take it away, Jana.
Thanks, Tyler. At a super high level, QUIC was designed to replace TCP for the web. Now, this is not a small task. As you know, TCP has been driving web and internet traffic for over 4 decades now. So we built QUIC as a much needed upgrade of internet transport. Now, we built QUIC and we designed QUIC with four key goals in mind. The first one was increased protection of the protocol and of the user data that it carried. The second goal was increased resiliency to common failures and the network conditions that are more common to applications and networks of today. The third goal was to have much better alignment with HTTP. Remember that HTTP was built after TCP, so HTTP was retrofitted into TCP, and we are now designing QUIC with HTTP as a primary use case in mind. So that should give us much better web performance. And finally, deployability and extensibility were a super important goal for us as well, meaning that we wanted to continue experimentation with and allow for continued evolution of the protocol as the usage and as network changes going forward. These are very exciting times for QUIC, and we at Fastly are not just looking forward to seeing QUIC get deployed, but we are also driving this, what we think of as an internet-wide upgrade. This is happening right now, and you should expect to hear a lot more about QUIC over the next year.
I think the thing to take away from Jana's points is just how fundamental a change QUIC is for the internet. On the surface, and what most people know it as is just the new underlying medium for HTTP, but it's so much actually more than that, right? The fact that encryption is built in from the start is super important. It means that rather than starting from a place of how much of this can we encrypt, we start from a place of how little of this can we avoid encrypting. Security ends up being the default for this. So that trust, performance, and flexibility is about more than just network protocols, right? We care a lot about network protocols, but Fastly is much more than that these days. I think one great example of this is WebAssembly, which is the base on which and the ecosystem in which we've built our Compute@Edge product. Recently, we started greatly expanding the team at Fastly, which works on WebAssembly itself, because it's become such a core part of our platform and vision. And I really wanted you to hear from someone on that team. Let's hear from Luke Wagner. Luke also works here in the Office of the CTO at Fastly. He's the co-creator of WebAssembly. He's the co-creator of AssemblyJS. He's also an expert on JavaScript and WebAssembly compilation and optimization, having worked on it for many years now. So let's hear from Luke.
We started WebAssembly as an open standard to give web developers more choice and better performance. Since then, WebAssembly has grown beyond the browser, for example, into products like Fastly's Compute@Edge. Based on the wide variety of usage we're seeing, there are several dimensions of improvements that we're working on in the community group. First, we want to enable WebAssembly to take better advantage of the CPU while maintaining safety and portability. This includes the SIMD proposal, which exposes vector instructions, the threading proposal, which exposes multicore, the WASM64 proposal, which exposes 64-bit address spaces, and several proposals which expose native stack manipulation. A separate dimension of improvements we're working on is allowing WebAssembly to better integrate with the host. This includes the GC proposal, which allows reusing and interoperating with the host's native garbage collector, the module linking proposal, which enables efficient dynamic linking, The WASI proposals, which define interfaces for common host resources like files and sockets, and the interface types proposal, which allows WebAssembly interfaces to be efficient, ergonomic, and safe. Altogether, these proposals will allow pure WebAssembly to do more faster.
In addition to Luke's points about all the work going into performance and security for WebAssembly, there was another point that Luke made that I think is worth repeating. He said WebAssembly is about choice. I think about that as choice in the languages used, as well as choice in how and where it's possible to deploy software. So again, this comes back to trust, performance, and flexibility. Now, relatedly, there's another side to our advocacy and development within the WASM community. Rather than explaining that, I'm going to let someone who does it far better than I do tell you about it. That person is Lynn Clark. She's the co-founder of the Bytecode Alliance. You may also know her as the creator, writer, and artist behind Code Cartoons. Tell us about this, Lynn.
WebAssembly was created to solve a problem in the browser, but it wasn't long before we started seeing how it could provide value far beyond the browser-based use cases that we originally had in mind. Many of the properties that made WebAssembly so useful inside the browser also made it useful in the cloud and on the edge. The portability across different kinds of machines, combined with security and incredibly fast startup times, that had the promise to change the way that we approach all sorts of problems. But to deliver on this promise, we realized that we needed to put a few more pieces in place. For example, we needed portability across different operating systems, not just different ISAs. And we needed a way to ensure that untrusted code within an application couldn't hijack the system. That's why we started standardizing a system interface for WebAssembly called WASI, which uses a capability-oriented security model. Together, WebAssembly and WASI give us a portable way to deploy software that has strong, fine-grained security guarantees. And this is a paradigm shift that enables entirely new use cases. What if we could take this paradigm shift even further? What if we could apply these fine-grained security guarantees not just at the application boundaries, but also within an application? This way we can make it much safer to reuse code from open source developers. And we can evolve WebAssembly from a compilation target that you compile monolithic applications to a modular ecosystem that you compose secure applications from. But we can't do this on our own. Building this ecosystem requires insights and expertise from across the industry, from low-level CPU architecture to operating system internals to language toolchains. This is why we created the Bytecode Alliance. It brings these experts together from across different organizations and specializations, so we can build these new software foundations as a community.
As Lynn says, we can't do this on our own. Building a platform like Compute@Edge and working on the underlying technology WebAssembly isn't actually enough by itself. For a fundamental leap like this, and again, as Lynn said, it requires working with languages and browsers and operating systems and chip designers. It requires fundamental change to achieve the trust, performance, and flexibility that we're trying to bring to you. It seems to me that a key part of all these initiatives that we just talked about is that they have two sides. The first is iterative and immediate improvement for you and for your end users. The second is actually about opening up new possibilities that have either been impossible before or just unrealistic. In many ways, this is actually about creating opportunities for our customers to view and use the internet in the same way that only the very largest of large tech companies have ever been able to in the past. It's about leveling the playing field to give you the capabilities that previously would have been out of reach. It's also about leveling the playing field in a different way. Now, if you've seen me speak at Altitude before, you've probably seen me use this particular tree image as a metaphor for the network and how I view edge computing. Today, I want to use it differently, though. If half the leaves of this tree were malnourished, they're turning brown, they're dying, we would say that that tree is unhealthy, right? The internet of today is actually not so different than that. The applications, speed, and experience that we all enjoy isn't available to everyone. And changing that is actually really hard. One might say it requires a leap, real fundamental change. There are many use cases and exciting possibilities for QUIC, WebAssembly, HTTP 3, and so on. But to me, the most exciting part is that we can use it to make the tree healthier. QUIC is good for everyone, for example, but did you know that it disproportionately helps those who are on poor internet connections, possibly in far-flung places? WebAssembly is exciting for many reasons, but one of the most exciting use cases to me is the concept of mobile offload, which is the idea of moving computations that might typically have been done on a powerful mobile device like an iPhone or a powerful Android onto the edge of the network if that user is on a low-powered device that can't handle it. These technologies are going to create a better internet for everyone, and Fastly is at the center of making that a reality. So thank you.